last section for chapter 12, and actually the last section we're going to go over, okay? It's still volume, but we're looking at pyramids and cones now. So it's just a matter of, again, kind of being able to use a formula, okay? So if you take a rectangular prism and you sink one of the sides, so one of the bases, okay, down to a point, you're going to get a pyramid. So it still has that rectangular base. Let's see if I can draw one. Okay. Except now, instead of coming to a rectangle here, it comes to a point. Okay. So a pyramid is a three-dimensional figure that has a polygon as a base. Okay. And then the sides are triangles. That all come to the same point. They share a common vertex. And the base of this pyramid can be any polygon. So it can be a square, a rectangle, a parallelogram. It could be a pentagon, okay? But it's just some polygon. And then the faces are all triangles. Then if you take a cylinder, so circular base, okay, and shrink one of its bases down to a point, you get a cone. It kind of looks like this, okay? It's going to be a geometric solid. So this is a pyramid. A cone is a geometric solid that has a circular base and one vertex. We can't really say that it has a face because if you think of like an ice cream cone, it's not really flat faces, okay? So it just comes to a single vertex. And that's what we have for a cone. So both cones and pyramids have a flat base and then they rise to a point, okay? On a cone, the lateral face is a curved figure or a curved surface. For a pyramid, their faces are all triangles. So when you look at both of these, it's going to take, well, for a pyramid, it's going to take 3 pyramids to fill in a corresponding prism. So that suggests to us that the volume of a prism is going to be, that the volume of the corresponding prism is 3 times the volume of the pyramid. So it tells us that the volume of the pyramid is going to be 1/3 the area of the base times the height. Okay, so find the area of the polygon, multiply it by its height, and then by 1/3. The same thing happens with a cone. It takes 3 of them to fill in the circular cylinder, okay? So the volume of a cone is 1/3 times the base, or area of the base, times the height. So the cone is unique because the base is always circular. So it's 1/3 times pi times the radius squared times the height. Okay? So if you have a cone with a radius of 5 centimeters and a height of 1.6 centimeters. Then the volume of this cone is 1/3 times pi times 5 squared times 1.6, or 41.9 cubic centimeters. And that should have a cubic here in your notes. Okay? So you just have to find the area of the base, multiply it by the height, and then when it's a cone or a pyramid, multiply that by 1/3, and that will give you the volume of the entire figure.